Welcome back, Mindsetters. It's just the beginning of your grade 12 session, Learn Extra Live, and I think that's exactly what we're going to be doing, is learning more and learning extra. Today we're chatting about surface area and volumes, and I know that Peter has some awesome things lined up for you, so if there's anything you've been struggling with, guys, please paste it onto our Facebook page, and that's www.facebook.com/Learn Extra. Also, our Twitter handle is @Learn Extra, and Peter, a Twitter handle is our Twitter name, just in case you want to add us after the show. So let's get to it, Peter.
Okay, so calculate the areas of the following shape. Our first shape here is a circle. It's supposed to be a circle. Does that look like a circle to you?
It does look like a slightly squashed version of a circle, but I believe that that's a circle.
Okay.
It's only on our screen, but on the learner screens, it's a complete circle.
Oh, really?
Yeah,
okay.
yeah.
Okay.
Yes.
And from this camera, can you see? I thought our producer just sat on it, and it can't. Anyway, right. So area. Let's go here. There we go. Area. We said before the break, the area of a circle is pi times r squared, which is 3,142 or 3,14 is what they've been saying in the latest matric exams, times the radius. What is my radius? It's 5 centimeters, and we're going to square that. Why are we squaring it? Because the formula tells us to. And when the formula tells you to do something, you just do it, okay? Equals. A formula is very much like a wife, all right? Formula says do something, you do it. And when my wife says I must do something, I do it, eh? Because I'm scared. So when we do that now, let's carry on here. We're going to say, right, with my calculator, we're going to say I have 3.14 multiplied by 5 squared equals, voila, there's my answer, 78,5. So my answer now is 78,5 centimeters squared. Okay? Straightforward. That's like the most basic of basics kind of questions. Grade 12s, you're not going to get something like that. So why am I showing you this? Just for revision purposes, because we're going to get to more complicated questions just now. In fact, let me show you this. I brought this shape in here. It's a little piece of wood with a hole drilled through. Okay? If I have to be honest, it's Indiana's wedding ring. But there it is there, a little funny square with a hole in it. So how would this kind of thing fit into it? Well, I could actually say I'm wanting to paint it gold. So at least Indiana thinks she's got a gold ring. So we're going to paint it gold. How much area do I need to paint? So what we would say then is, well, let's calculate the area of the rectangle. Let's calculate the area of the square. And then we can say it's going to be the rectangle, sorry, not the square. What am I talking about? Circle, eh? Mm-hmm. Let's take the area of the rectangle, subtract the area of this little circle over here, and that'll give me the area that I need to be painted. That's how we're going to apply the basic concepts in a more complicated question than this little thing. Another shape I have here is this funny shape over there. Okay, now I don't know what camera to look at. Okay, here we go. There you are. Right, here's a fun little shape. It's called a cylinder. And it's kind of round, and if I were to say, let's calculate the surface area, well, we'd have to calculate the surface area of this whole thing going around, and then also the area of the little circle. So it's a basic little concept, but you can't calculate the surface area of the entire cylinder unless you know how to do that. So this kind of question would fit into a more complicated question. When I open this, this is quite impressive. I must show you this. Okay. This is a degree that one of our producers has. Okay,
John.
And his name is John, and it's a degree in.
Yeah, all of the learners know John. John is a famous person around here.
Oh, is he?
Have you know, Peter?
Okay.
Yeah.
Well, John has a degree which I think he printed from Word document or something, because he stuck a little thing in here. But anyway, this degree is kept in this little container, and this container is called a cylinder. To find the surface area of the cylinder, we're finding the area of this round container plus the area of the circle. Guys, and that's where the basic concept comes in. So we wouldn't ask you a basic thing, we would actually ask you a more complicated question, but you've got to do the little bits in between. I'm going to put this down. I'm going to hand it over to Indiana. She's never had a degree handed over to her before, so it's a new experience. Well done.
I actually do have a BA. Can you believe it? He doesn't. He doesn't. I'll tell him after the show.
Right, next question. Calculate the area of the following shape. So here now I have a funny looking triangle. Now we said that the area of a triangle is equal to half times the base times the perpendicular height. Okay, so my base is 20 centimeters. So there she is there, 20 centimeters. Now what is the height? Well, the height is not this height. It's not going to be this height, but it's this height over here. Right. So this is the height. So I need to know this height in order to calculate my area. Now, just looking at this question, we haven't quite been given enough information to answer it, because to find that I should actually know what this distance here is, because then I can use Pythagoras to find out what the height is. But sadly, John, who has this phenomenal degree, gave us a wrong question. So we'll move on there and we'll look at the very next one. So here we go. Calculate the areas of the following shapes. Now here we have a trapezium. And folks, when you're given a trapezium, you will be given the formula for it. And they will say that the formula for a trapezium is the area is half times the sum of the parallel sides, okay, times the height. Now, what do I mean by parallel sides? Well, these sides here, and you'll be told on an exam, would be parallel. So what is the area of the shape? It's going to be a half multiplied by the 60 kilometers plus, because the word sum means plus the 45 kilometers times my perpendicular height. Remember, it has to be the perpendicular height. It can't be this height, it can't be that height, it's got to be that height. So times 50 over there. And then we just take out our calculator, and our calculator is going to do everything for us. Okay? So we're going to delete the previous thing, and we're going to say, right, my area is 0.5, bracket, the sum of the parallel sides, 60, multiplied, no, not multiplied, plus, because it's the sum, plus the 45, close the brackets, times my perpendicular height, which was 50 kilometers. And my answer is 2,625. Okay, so my answer then is 2,625 kilometers squared. Aha, now let's stop for a minute and talk about our units. When we deal with perimeter, we are saying if we're adding up centimeters, our final answer is in centimeters. If I'm dealing in area, it's centimeters times centimeters. My answer will be centimeters squared. If I'm dealing in volume, which we'll do later on, my units are going to be centimeters times centimeters times centimeters, then it's centimeters cubed. So I look at how many centimeters I'm multiplying together. If I'm multiplying a centimeter times a centimeter, I'm obviously dealing with area. My units are centimeters squared. If I'm dealing with volume, it's going to be centimeters times centimeters times centimeters, centimeters cubed. And when I say centimeters, understand it could also be kilometers squared, kilometers cubed, okay, or meters squared or meters cubed, right? So please understand that with the units. Area, always squared. And you know what, guys? Oish, holy cow. When I mark exam papers at the end of the year, I'm just absolutely horrified at how many matrics forget to put the units in. So they will say the area equals so many kilometers, full stop. And I kind of turn the page to see if I can see the squared, but it's not there. Okay? Got to be squared. Even volume. You guys will say 3 meters times 2 meters times 1 meter equals 6 meters. And it's like, where's the cubed? It's not there. Okay? Got to have it because you want those marks. How sad, isn't it? When we work, when we understand something, but we make a careless mistake, and so we lose a mark. That's just criminal. Right. Let's move on. Our next question. The area of the circle is given by, oops, let's just try and get this down here, shall we? Okay, she's not going anywhere, so we'll just go here. The area of a circle is given by area equals pi r squared. If the area of the circle is 53,94 centimeters, what is the radius? Aha, now this is a different type of question, hey? In this question, they now are saying, right, we're going to give you the area, and now that you have the area, you now find the radius. Before they gave us the radius, we had to find the area. So let's have a look at this. We're going to say, okay, so area is pi times r squared. We know what the area is. The area is 53,94 centimeters squared equals pi times r squared. What are we trying to find? We are trying to find the r squared. And so in trying to find the r squared, we need to take everything else to the other side of the equal sign. Now, if you're a maths teacher and you're watching this, just block your ears, because I'm going to say something that drives maths teachers totally insane. But that's okay. I enjoy doing that. But every time we cross over the equal sign, we're going to change our sign. So here I have a times. When it crosses over, it becomes a divide. If I've got a plus, when it crosses over, it becomes a minus. So my r squared now is equal to 553,94 divided by pi, which is 3,14. Are we clear on that? Okay. So let's work it out. With our calculator, we are going to say, in Indiana, I'm going to need you to write this down. So hopefully you are paying attention.
I am.
So on our fraction button, we've got 53.94. We're going to divide it now by 3.14. Now watch this long answer, hey? Carries on forever. 17,17834,395. Got it? Cool. Let's move on. So we've now got the answer here. Indiana's eyes have just suddenly got very wide.
I hope
she couldn't get that down at all, but nevertheless. So we've got this answer. What was it, Indiana?
17 point.
Yeah, blah, 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 blah.
3, 4,
Okay.
5.
Equals r
9,
squared.
5.
Now, we don't want r squared, do we? No, we don't. We want the radius. The question never said, what is the radius squared? Why we wouldn't want to know that? We want to know what's the radius. So what are we going to do with this radius? Now, if it's squared and we're going to cross over our bridge, squared one side, we cross over becomes square root. So we're going to say the r is going to be equal. We're going to have to get rid of more of our bridge here, and there goes Africa. Okay, there she's gone. Now, r is, we're going to take this number and we're going to square root it. So there's my number on my calculator already, 17,17. We're going to say, right, square root my answer. Now, this calculator should say answer. Here it is. Equals, and there's my answer, 4,14. So what is my radius? My radius is going to be 4,14. 4,14 what? We're dealing in centimeters. It's going to be centimeters.
Fantastic.
Sure.
Peter, I do have a question. It's from Naledi.
Hi, Naledi.
Naledi wants to know, what is the formula for perimeter in a circle in a trapezium? I think trapezium?
I'm not too sure I know that question because a trapezium and a circle are two entirely different shapes. And the formula for a circle is always the same, hey? The perimeter of a circle, which is like the circumference of a circle, is 2 times pi times r. So if the circle is inside a trapezium, the formula for that circle is still the same. I'm not too sure on the question she's trying to ask.
Okay, Naledi, what I need you to do is, lady, please let us know what you mean by your question, but I think hopefully Peter's answered your question. It always stays the same. Fantastic, Peter. Thank you.
Okay, cool. Shall we move on?
Yeah, let's move on. I'll let you know if she writes back.
Okay, cool. And let me know if the producer's shouting at us about a break or
yes,
something.
I will do that.
All right. So let's go here. Now, if the area in 1.2 is doubled, now what was the area? Do you remember the area? What was the area? Let's go back. Voila, we're trying to go back. The area is 53,94. Can you remember that for me? 53.94? Cool. Now the question is this. If the area is doubled, what would the radius now be? Now you're going to think, well, if the area is doubled, the radius must be doubled. I wonder if that's true. Let's have a look at it. Okay, so my area was...
Your area was 53.94.
53,94. We're going to double the area. So we're going to take our calculator and we're going to push a few buttons. Here we go. We're going to delete that. And we're going to say, right, I got 53.94. We're going to double it. How do we double something? We either say plus another 53.94 or times 2. And that's what I'm doing here. Okay? And my answer now is going to be 107,88. Got it? So 107.88. So my new area is 107,88. So if my area is doubled, what's going to happen to my radius? What was my radius here? What was my first answer? Can you remember?
Wasn't it 17? That's not the 17 point,
No,
blah, 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 blah.
Let's just have a look here. My radius was initially 4,14. Okay? So when we had my first area, my radius was, what did I just say?
4,14.
There we go. Jesus, I'm really battling with this age thing. I used to have such a good memory, and then my age with age, I think it's because my wife hits me. I lose a brain every now and then. All right. Okay, so my new area, my wife doesn't hit me, by the way. My new area is 107,88. What's the new radius going to be? Let's look at our formula. We know that area of a circle is pi times r squared. We know the new area is 107,88 equals pi, which is 3,14 times r squared. Now you sitting at home, wait, camera here. Cool. Now you guys sitting at home, just ask yourself quickly, if I double the area, does that mean my radius is doubled? Quickly answer that in your mind. Tell your buddies at home, tell your mom, tell your dad quickly. Yes it does or no it doesn't. Let's see. 3,14 times, take it across, we're going to divide. So my calculator now, I'm going to say, right, I've got 107,88. I'm going to divide that by 3.14 equals, and I'm going to get an answer here of 34,3566. So it's 34,35 blah blah blah, a whole lot of things, and that is equal to r squared. I don't want r squared, I only want the radius. So my radius now is going to equal what? Well, we're going to take this number and I'm going to square root that answer, and my answer is going to be 5,86. So my new radius is, here we go, 5,86. Here we go, radius is 5,8. Hello. It's not doubled at all. So why not? It's all in the secret of the squared here that I've got. Okay. So guys, don't fall for that trick. Don't say, because the area is doubled, the radius has got to be doubled. And don't say, okay, I'm doubling the radius, so obviously the area must be doubled. It doesn't work like that because we've got that little squared sign. Okay, let that be a valuable lesson. Should we carry on, or do you have another question?
Let us carry on. Let's carry on. Yeah, we've got about 10 minutes left, guys. So if you guys do have any questions, squeeze them in quick. Carry on, Peter.
Okay, next question. This is a nice Pythagoras little one. Calculate the length of the hypotenuse. Yo, that's a big word, eh? It's like hippopotamus. It's a big animal. Hypotenuse is also a big word. And hypotenuse, like a hippopotamus is a big animal, hypotenuse is a big word. And so we're talking about the big side or the longer side. And my longest side is this one here, AC, right? Because it's going to be opposite my 90-degree side. And unfortunately, and we are going to have a word with him. The guy who put this together forgot to put that 90-degree sign in this. John, if you're watching, wait, okay? Guys, dealing with the right angle triangle here because we're speaking about a hypotenuse, so we should know that there's a 90-degree angle there. So, AB is 2 meters. This side here is 2 meters long. We're told that BC is 6 meters. Okay, let me interrupt myself again because I enjoy doing that. Guys, if you get a question in an exam and they're giving you a whole lot of measurements, put them in on the diagram. Don't try and look at a blank diagram with all the writing up there. Put the writing on the diagram because it makes your life so much easier. Because then you can see straight away, hey, I know what I'm looking for. There it is. Okay? So AC, we're trying to find AC and I'm going to say, okay, AC squared according to Pythagoras, remember the long side is equal to the square of the short side plus the square of the other short side. What's that going to give me? Well, we know 2 squared is 4. We know 6 squared is 36. So the length is going to be 40, the AC squared. We don't want AC, we just want we don't want AC squared, we just want AC. So we're going to say, therefore, AC is the square root of 40. So how do we find the square root of 40? Well, we don't do it. Our calculator does it for us. We're going to say we're going to find the square root of 40 equals, voila, 6,32. So 6,32. 6,32 what? We're dealing in meters. Okay. And that's just another way of finding perimeters. But folk, understand, and again I'm stressing this, but tricks, you're not going to get something so basic. It'll be part of a whole question. How could it be part of a whole question? Let me show you this tin here. My poor producer's running around trying to find me on camera. But I'm back here now again, okay? So here I have a tin. It's not a normal tin. In other words, it's not a rectangle and it's not a circular tin. But if you were to look at the shape of this tin, you can see that were I to cut off the ends, I would land up with a rectangle. Okay? And were I to cut all this other off, I've got a semicircle. And this side here, I've got a semicircle. So what I could say to you is calculate the area of that shape. Wait, now it gets interesting. Because now I've got to calculate the area of half a circle, plus the area of the other half a circle. Okay? Or I could actually pretend they would just join together and calculate the area of a whole circle. But it's the area of half a circle, plus the area of the other half circle, plus the area of the rectangle. And by doing that now, I'm adding up those 3 bits to find the whole area of that. It's going to get even more interesting when I try and find the volume. In other words, I pop off the lid and I say, how much space is inside this tin over here? Now we're going to land up with an even more interesting question. But we don't have time for that. We will do that again at another time. Just incidentally, this whole series here, where we're looking at perimeter and area and volume and surface area, is going to take us a good 3 weeks. It's a very important section. Hey? It actually counts about 25% of your final matric exam. So we're going to really spend some good quality time. So today is all about just doing a little bit of revision, and next week we're going to start with the real manly stuff. Or in your case, the real womanly stuff.
Ladylike stuff.
That's it.
Talking about ladylike stuff, I do have a question from Dolly.
From Dolly?
From Dolly. And Dolly wants to know, she says she's a bit lost. Do we have to double the radius?
No.
No.
No. No,
No, Dolly.
Let me show you this. Okay. The radius, oops, let's get a pen first before we show you this. The radius squared is not the same as 2 times the radius. Radius squared is not doubling the radius. What's her name? Dolly.
Dolly.
Yeah, Dolly, please, never ever think that. Get that out of your mind right now. Let me use an example. Let's pretend our radius is, I don't know, let's make it 10 centimeters. Okay? If I were to take 10 centimeters and square it, 10 times 10 is 100. So you're going to get 100. Now, if I say 2 times 10, I'm now getting 20. Guys, that's not the same thing at all. And Dolly, I'm glad you've asked that question, because so many matrics in their final paper do that. They say r squared equals, and they say, oh, that's easy. The radius is 10, so r squared is 20. No, it's not. So thanks for that question. So take that concept, take it out of your mind and throw it away. All right? Don't let that into your mind. If you want to know in more detail how to take something out your mind, ask Indiana.
Oh, or don't. Hey?
Shall we move on? Or
Yes.
do you have another question for me?
Let me have a look. No. Okay, wait, we've got a question. New radius. Is it 5,86 potatoes? Tell him to remember units. What is this, Martin Albani? I think he's trying to tell a joke. I think carry on, and if there's any questions, I'll jump in. We've only got 2 minutes.
Only got 2 minutes left.
I know.
My goodness, these Thursdays, the time just flies, eh? It's really, really quite amazing. Okay. Calculate the length of the side PQ. Okay, to get that though, we've got to get Q in on the picture. If QR, we know QR is going to be 10 and PR is 4. Okay, so now we need to calculate this length PQ. You know what, seeing we've got such little time, I'm actually not going to do it myself. I'm just going to explain what we've done, because we've just done one very similar. So what we're trying to find now is we're trying to find a short side. So we're going to say it's equal to the long side squared minus the short side. So I'm going to land up with 100 minus 16, okay, which is going to give me, what's it going to give me? 84. And so PR is going to be the square root, or sorry, PQ is going to be the square root of 84. All right.
Have a great day. Bye, guys.